All right, so this is super similar to one of the 3 open-endeds that you have on your final exam. So what you need to recognize is that if you have something that has a root, anything that has a root can be taken out of the root. The only way to take something out of the root is to give it a fractional exponent, okay? Anything inside of a root has to have a fractional exponent. Like these have fractional exponents, I can write them as a root. I can do the opposite too. So what we talked about yesterday was we had this formula. And this formula works both ways. So we were really working with it starting with the fraction and working our way backwards. But it works if you start with the root as well. So the outside number becomes the denominator of your fraction. So that 4 that's on the outside is going to be the denominator of my fraction. If I want to take the 256 x to the 18 out of the root, I need to give each part of that an exponent that's a fraction. There are 2 parts of that. There's the 256 part and the x part. So both of those get fractions. The denominator of both of those fractions is the outside number, which is 4. The x already has a numerator because the inside exponent is 18. But the 256 doesn't have a numerator. In other words, the 256 doesn't have an exponent. What could I put? 1. So I'm going to filter in a 1 here. And I'm going to put a 1 here. Now, before I call it quits and say this is my final answer, I have to do 2 things. I have to type this into the calculator. And I have to see if it becomes a whole number. Because if it becomes a whole number, I'm going to change it. But if when I type that into the calculator, I get a decimal, I'm going to leave it as is. So it just depends. So if I type 256 to the 1/4, and make sure you're taking a moment to do that because some of your calculators require parentheses around the 1/4 and some of them don't. So if you type 256 to the 1/4 in your calculator and you don't get 4, then your calculator needs parentheses when you do this. Some do and some don't, so I just really recommend you checking that when you type 256 to the 1/4, you get 4. If you don't, you need to use parentheses around the 1/4. Then you should get 4. All right? So because that's a whole number, that means I'm going to change the 256 to a 4. Now, the second thing I have to do is I have to check to see if this simplifies. And to do that, I can just do like a math enter. So I'm going to do 18 divided by 4. Math enter. And it does, it simplifies to 9/2, so I'm going to change it to 9/2. Anybody have questions on that one? I want to write the answer in exponential form, meaning I want exponents at the end of my answer. I don't want roots. The second one says write the expression in radical form. So I want roots now. All right, so because the 384 has an exponent and because that exponent is a fraction, I can write the 384 inside of a root. The numerator of the fraction stays inside, the denominator of the fraction goes outside. And I can do the same thing to the x because the x has an exponent and because that exponent is a fraction, I can write it as a root. The numerator stays inside, the denominator goes outside. What's 384 to the first power? It's just 384. If you don't know that, you can type it into your calculator. 384 to the power of 1. It's just 384, so I don't need that power of 1. All right? So the first thing that I'm going to do with that number is I'm going to math 5 it, and I'm going to see if it reduces nicely. So math 5, this is the 7th root of 384. If this is a whole number, then I'm just going to write it as a whole number. But if it's a decimal, where do we have to go? Y equals. So I'm going to go 384 divided by x. What I am looking for is a perfect 7. Is there someone out there who's got their sheet who can read to me the x to the 7 column? What is it? 128? 2001. All right, so if you don't have your list, here's what I'm looking for. 2,187. All right, so I am looking for one of those numbers to show up in my table. All right, so I did a 384 divided by x. I see a 128. All right, so I'm going to use the 128 and the number next to it, which is 3. So I'm going to split this into 128 and 3. Again, that's coming from the x to the 7th list. Now I'm going to math 5 each of these. And you'll see that one of them works out nicely and the other one doesn't. Instead of writing all of those decimals, I'm going to keep that as the 7th root of 3. But I'd rather write 2 than the 7th root of 128. 2 is cleaner, right? It's shorter. So I'm going to change the 128 to a 2, and I'm going to keep the 7th root of 3. Right? That's how we reduce numbers. We type them in math 5, and if that doesn't work, then we go to the y equals. And we're looking for perfect 7s here because it's a 7th root. But if it was a 5th root, you'd be looking for perfect 5s. All right? Variables work differently. For variables, we want to think about multiples of 7, right? The outside number. Multiples of 7. So 7, 14, 21, 28, 35, 42, 49. That's 7 times 7. 7 times 8 is 56. 7 times 9. 63 is too much, right? So I know I'm going to stop here. You want to go underneath the number, right? So I'm going to break this up into x to the 56th and x to the 3rd. I still need those two numbers to add together to 59, and 56 plus 3 is 59. Once you have that split up, for the variable, you're not going to math 5 that. You're just going to do the inside number 56 divided by the outside number 7. And that's going to give you an x to the 8th. If it divides out evenly, you just get rid of the root. And when the inside number is smaller, that's when you leave it alone. And then from here, I'm just going to reorder some things. So I'm going to put this 2 next to this x to the 8th because they both came out of the root. And then I'm going to put these roots together. So my final answer here is 2x to the 8th, 7th root of 3x to the 3rd. Because this is a final, because it's worth 20% of your overall grade, I highly recommend taking the time that you have to check your answer. You can check both of these. Here is how you would check the first one. I would go into y1, and I would math 5, and I would do the 4th root of 256 x to the 18th, right? That's the question. Our answer was 4x to the 9 halves, I think, right? Is that what we said the answer was? If this is right, the table will match for everything. If it's wrong, it will not. Unfortunately, for open-ended, all it's going to do is tell you if you're right or wrong, but at least that's better than you just blindly handing it in, right? At least you'll know you can go back and look at some things. So you can see that this matches perfectly, then my answer's good. All right, for the second one, the way that I would check it is in y1, I would type the question, which was 384, right, to the 1/7. And then x to the 59/7. Right, so that's what the question was. My answer was 2x to the 8th. Now, when you're doing this next part, you have to hit the times. Otherwise, when you math 5, it's going to take this and it's going to put it into the root. You want to separate them, so you just times. And then you math 5, 7th root of 3x to the 3rd. Right, this is what we think the answer is. And you can see it is because everything matches. So take that extra minute or so to check your answers. This is definitely one of your 3 open-ended concepts. All right? Today in class, we are going to review your polynomials unit. We're going to review your polynomials unit in 2 days because there was a lot to that unit. So today we're going to do the add, subtract, multiply, and we'll start to review some of the factoring, but we won't do all of it. We'll finish the factoring tomorrow. Factoring is the most important thing that you've learned all year. It is heavy on your final because it's so important. So I held it off to the end because I wanted you to review it right before you took final. You start the final on Friday, all right? So your review today, we're going to start on page 4. Add, subtract, multiply, divide, all right? So the key here is that you recognize what operation's being done. So this problem right here, there's a plus sign, so I'm adding them. I'm subtracting them, and there's nothing in the middle here. So what does that mean if there's nothing in the middle? This one's multiplication. Right, there's like a constant, all right? Adding and subtracting, we do those similarly. Multiplying is different, all right? Adding and subtracting, it's all about combining like terms. But if you see a parenthesis, our initial instinct when we see a parenthesis is to distribute, right? So I need to get rid of these parentheses by doing the distributive property. If there's nothing in the front to distribute, what do I put? A 1. So I'm distributing a 1 here. 1 times 2x to the 3rd is still just 2x to the 3rd. 1 times 5x. 5x, and 1 times negative 9 is negative 9. There's nothing in front of the second set of parentheses either, so I'm going to put a 1. 1 times negative 3x to the second. 1 times negative 4x. And 1 times 2. All right. By distributing, I've gotten rid of the parentheses. Once you get rid of the parentheses, you're going to combine the like terms. Like terms are things that have the same exponent and base. So when I'm looking at this term right here, there's no other like terms with that one. There's no other x to the thirds in this problem, so I'm just going to leave that one alone. All right. When I'm looking at this term, I'm going to go with the squared next because we go in descending order. There's no other terms here that have a square, so I'm just going to leave that one on its own. When I look at the 5x, I've also got a negative 4x. Those are both x's, which makes them like terms. So I'll do positive 5 minus 4, which is 1x, or just positive x. And then negative 9 and positive 2 is negative 7. If this were a multiple choice question, you could very easily guess and check the answer. Type that into Y1. Type option A into Y2. Check the table. If that doesn't match, clear Y2 out, type option B into the table. Check the table. You can do like 90% of the multiple choice questions if you know how to use your calculator. Probability is a little iffy in that sense. I think that's the only unit you really can't do this in. Any questions on the first one? All right, now the second one becomes a little different. Not for the first set of parentheses. I'm still just distributing a 1. So 1 times negative x squared, 1 times 8x, 1 times negative 4. But the second set of parentheses, everything's going to change. A lot of times kids will just like add these together and say that the answer is 5x squared. And it's not. Okay, so I've got to do negative 1 times 6x squared, which actually makes that a negative 6x squared. A negative 1 times a negative x, that double negative makes it a positive x. And negative 1 times negative 1 makes that a positive 1. The second symbol, the symbol on the second set of parentheses changes for everything, right, when you're subtracting. Because I'm doing minus 6x squared, minus negative x, that double minus becomes a plus. Minus negative 1, that double minus becomes a plus. After you do that first initial step, now you're just combining your like terms. Like terms have the same variable and exponent. So this is like negative 1 plus negative 6. So this is negative 7x squared. 8x and 1x. That's 9x. Negative 4 and positive 1. Negative 3. Same thing with this one. You could easily guess and check this by typing the question into Y1, option A into Y2, checking the table. If that doesn't work, clear out Y2, put option B in Y2, and keep doing that until you find a table that matches. This is addition and subtraction. When you add and subtract polynomials, you can only combine like terms. But when you multiply polynomials, the like terms don't matter. You can combine anything with anything when you're doing multiplication. So I am going to take this 3x in the first set of parentheses, and I am going to distribute it to the x plus 5. And I'm going to take this minus 4 in the first set of parentheses, and I'm going to distribute it to the x plus 5. So I'm splitting apart, with multiplication, I'm splitting apart the first parenthesis and giving each part of the first parenthesis the second one. I'm also going to go through and I'm going to put little ones on all of the x's that don't have them. Because right now we're going to do the multiplication property of exponents. We reviewed this yesterday. Multiply the numbers in front, keep the base, add the exponents. So this is like 3 times 1. Keep the base, add the exponents. So 3x times x is 3x squared. 3 times 5 is 15, and there's no x's to combine, so I'll just keep that x the same. Negative 4 times x is negative 4x, and negative 4 times positive 5 is negative 20. From here, we're combining the like terms. Like terms are the things that have the same variables and exponents. Once you do the multiplication, it becomes an addition and subtraction problem. And when we add and subtract polynomials, we can only combine their like terms. 3x squared, 15 minus 4 is 11x minus 20. You could easily guess and check this with a multiple choice question. Put the question in Y1, put option A in Y2. Check the table. If that doesn't work, try B. If that doesn't work, try C. One of the tables are going to match, as long as you type it in your calculator the right way. This is a track. You are going to choose this. Every year we analyze the data, and this multiple choice question is the most incorrect one every year, because kids think that they can just take that 2 and distribute it in. That's not the way it works. What does it mean to square something? 5 squared means what? 5 times 5. So 2x plus 9 squared means 2x plus 9 times 2x plus 9. You gotta write it out twice first, and then do the multiplication. You are not just distributing in the 2. Once you write it out twice, you've got 2 parts. You're gonna take the 2x from the first set of parentheses and distribute it to the 2x plus 9. And you're gonna take the plus 9 from the first set of parentheses and distribute it to the 2x plus 9. And I'm going to go through and just add 1s on those exponents so I don't forget to add them. So 2 times 2 is 4, and x times x, I'll add their exponents together. 1 plus 1 is 2. And 2 times 9 is 18, and then that x just comes along. 9 times 2 is 18, and then that x just comes along. And 9 times 9 is 81. Now that I've done all the distributing, it just becomes an addition and subtraction problem. So I'm going to add the 18 plus the 18. So my final answer is 4x squared plus 36x plus 81. Not 4x squared plus 81. Do not do that. This is the answer. This is another one that if you know how to use your calculator, you don't even have to do any of that. Like the question in Y1 and each option in Y2, one of them's going to match. Pick the one that matches. It's not going to be the 4x plus 81. All right? So let's just take a moment and practice those ideas. So you're going to go to page 16. Page 16 I think is kind of long. I don't think you're going to get all of it done in 10 minutes. Maybe you are. It's a lot of problems. But I'm thinking 10 minutes is enough time to practice. You can skip around if you want in that section. Do one addition, one subtraction, one multiplication, or something like that. But I don't want to take up your whole class with like just repetitive examples. So I feel like 10 minutes is enough time. After 10 minutes, I'm going to post the key. Don't forget you can use the Y1 and Y2 as a checking tool. All right? So 10 minutes will put us at, we'll say, 8:20. All right? All right, so again, you might not have gotten through all of these, but I'm still going to post them all just in case you picked and chose different problems than other people. So number 1, or A and B were both addition. Oh, thank you. Letter A and B were both addition, so I just distributed a positive 1. C and D were subtraction, so I had to distribute a negative 1. E, F, and G were all multiplication, so I had to do multiplication first and then combine like terms. I just have highlighted in different colors the like terms so you can see them a little bit better. Does anybody need those up still? There were more, so again, I'm not assuming that you got through all of these, but in case you did, just really pay attention to H, I, and J, how I wrote each of those parentheses out twice. I didn't distribute in the squared. I wrote it out twice. And then I did the distributive property. Addition, subtraction, and multiplication are really easy things to check in the calculator. So for example, if I was checking H, in Y1, I would do x minus 5 squared. And by slim chance, I had this brain collapsing moment where I just thought I'd distribute that in, and I get this. I can check that in the calculator and see that they do not line up, okay? Especially on multiple choice, this is a really good option because on an open-ended, sure, it's wrong, but what do I do from here? But on a multiple choice, if it's wrong, go to option B and do that, okay? And keep checking. So test-taking strategy, a really good test-taking strategy. All right. What I want to do for this second part of class is start the factoring review. I think it's really important to do the factoring review in two parts. Factoring is so important, I don't want to throw all of the review at you at one day. So we're going to go over 2 of the 4 methods that we learned today, and then tomorrow we'll go over the final 2. All right? So in your workbook, this is page 3, factoring. We're going to start with the A equals 1 method and the GCF method today. So we'll do the top boxes. Honestly, just because they're in the top. There's no real rhyme or reason why we're doing that today versus tomorrow. All right? So A equals 1 method. A few things need to be true to use this method. It's got to be a trinomial, meaning 3 terms. So you could write trinomial if you know what that means, or you can write 3 terms. It's got to have 3 numbers in the problem in order to use the A equals 1 method. The first term is x squared, no number in front. In other words, if I asked you to put a number in front, you would put a 1, which is why it's called A equals 1. And here's how to do it. You don't have to write this if you don't want, but it is a process. It might be something nice to look back at. You're going to take the C term and divide it by x. You're going to look for numbers next to each other that add to b. So what I want to do is I want to practice with that method before we do anything else, right? So there are examples on this page. I want to pull out the examples that we would use A equals 1 on, and I want to do those practice problems. So on your test, it's not going to tell you what method to use. You have to be able to look at all the problems and pick. So I'm looking for the problems on this page that have 3 terms, and the first term is x squared with no number in front. Do you see any of those on 1 through 6? 4 and 6 are both A equals 1 problems. So let's look at them. All right. They are A equals 1 because they have 1, 2, 3 terms. The first term is x squared. 1, 2, 3 terms. The first term is x squared. So what we're going to do here for the A equals 1 method is we're going to do C, which in this case is 12, divided by x into the calculator. We are going to look for numbers that add to b, and b is negative 8. All right, so you want to use the symbol in front of it. So I'm going to go to y equals, I'm going to do 12 divided by x, and I'm going to look for numbers that add to negative 8. When I figure out what those numbers are, they immediately go into the parentheses. In A equals 1, I don't have to worry about the first terms, because x times x will always give me x squared. And in A equals 1, the first term is always x squared. That takes care of that. I just need to work with the other 2 numbers. So I'm doing 12 divided by x. And I'm looking for 2 numbers next to each other that add to 8. Right now, all of my numbers add to positive things. 1 plus 12 is 13. 2 plus 6 is positive 8. 3 plus 4 is 7. Where do I got to go? Up. I got to go to the negatives. Negative 1 plus negative 12 is negative 13. Negative 2 plus negative 6 is negative 8. So my numbers are negative 2 and negative 6. And it doesn't matter if you put the negative 6 first or the negative 2 first. This is my answer. We can check it. X squared minus 8x plus 12. X minus 2. X minus 6. You can really check your answers for everything from this unit using that y1, y2 tool in the calculator. All right, we said that number 6 was a equals 1 as well, all right? It's a equals 1 because it has 3 terms and the first term is x squared. So I'm going to go to the y equals screen and I'm going to do 25 divided by x. And I'm going to look for numbers. What do I want them to add to for this one? Negative 10. I'm going to look for my numbers that add to negative 10. Once I have them, they're just going directly into the parentheses. I don't need to do anything else. The x times the x already takes care of the x squared. So let's go 25 divided by x. We want negative 10. So that's negative 26. That's negative 10, right? Minus 5, minus 5. So this would be a minus 5, minus 5. How else could I write that? Very good. It's twice, right? And when we repeat it, that's x minus 5 squared. All right, so both of those are a equals 1. Just kind of looking ahead, are there any on this group that are a equals 1? No. At least not initially. All right, so now we're going to go and we're going to fill in stuff for the GCF method. The GCF method's kind of like the dumping ground. It's like, if it's not anything else, then it's GCF. All right? So GCF can be any number of numbers. It could be 10 numbers. Usually it's 2, but it could be 3. It could be 4, it could be 5. It can't be 1 because you need to find something that 2 numbers have in common, so it can't be 1. It's got to be 2 or more, but it could be any number of numbers. So here's how we're going to do it. There's this button in your calculator, and some of you don't need the button in the calculator. You can do it by hand, but math arrow to the right 9 is going to help us get the GCF between our numbers. And then variables, if all of the terms have a variable, then the GCF has a variable. So in terms of numbers, we can use our calculator to get the number GCF. And in terms of our variables, we got to look at, do all of the terms have an x? Well, then the GCF has an x. Does one term have an x and the other one doesn't? Then the GCF doesn't. Okay, they all have to have an x. Once you figure out what the number and variable GCF is, you can divide it out from all of the existing terms. It's like the opposite of distributing in. GCF is dividing out. All right, so let's look at our examples and let's figure out which ones are GCF problems. Now I see numbers 1 and 2 and 3, 1, 2, and 3, all as 2 terms. So I'm thinking maybe they're GCF. So let's look at 1 and see if that's a GCF. Do both terms have an x? No. So there's no number there's no variable GCF. Now this term has a 1 and that term is a 196. So if I math arrow to the right 9 that. The number GCF is 1. Do you remember from this unit we said 1 is a GCF? All right. So number 1 looks like it could be a GCF problem, but it's not. All right. Let's look at number 2. Do both terms have a variable? No. So there's no variable GCF. Let's see if there's a number GCF between 49 and 16. No. Okay, so even though that's 2 terms, it's not a GCF problem. All right, let's look at number 3. Is there a variable GCF? No. The first term has an x and the second term doesn't. So let's see if there's a GCF between 12 and 75. is a GCF between 12 and 75. So even though I can't divide out an x, I can divide out a 3. So I'm going to write what I get when I divide out the 3. So 12 divided by 3 is 4. And then there's no x's in the bottom, so that x squared just stays. And 75 divided by 3 is 25. Does anybody remember the most important part of a GCF problem? You gotta write the GCF. Where does it go? In the front. It's the most important part, and it's the most forgotten part. It's divided out, and you always forget to write it in the front. You have to write it in the front. All right, so I factored out the GCF there. We already said number 4 was a equals 1, and number 6 was a equals 1. Let's see if number 5 has a GCF. We said it's usually 2 terms, but it could be 3, right? So if I were to check the GCF between this one, is there a variable GCF? Do they all have an X? No. But I could see if there's a GCF between the numbers. The way that you do that is you're going to math arrow to the right 9, the first 2 numbers. You can only do this 2 at a time. So I'm going to math arrow to the right, 2 and 16. Okay, so they have a GCF. And then I take that GCF and I pair it with the last number, which is 14. And I get the ultimate GCF at the end. All right, so even though it's 3 terms, there is a GCF. The GCF is 2. So what that means for this problem is I can divide a 2 out from all of them. X squared plus 8x plus 7. Don't forget the GCF. How many terms are inside of the parentheses? What's the first term? This is a equals 1 now. Right? There are 3 terms inside the parentheses. The first term is x squared. So, we're going to do y equals 7 divided by x. We're going to look for numbers that add to what number? Not 16, 8. The new b is 8. And those numbers are going to go into these parentheses. And that 2 is just going to stay in the front. So we did GCF by dividing out the 2. Now we're doing a equals 1. Anybody know 2 numbers that multiply to 7 and add to 8? There's only 2 numbers that multiply to 7, right? 7 and 1. So this one was GCF and a equals 1. All right, let's look at this last group. See if there's any GCF here. Number 7 is 2 terms. So it could be GCF. Let's look at the GCF between the numbers 10 and 18. Math, arrow to the right 9, 10 and 18. Okay, well, I can divide out a 2. Do they both have an X? So the GCF has an X. You pick the smaller of the x's. So this is x2, this is x1. I can divide out a single x. 10 divided by 2 is 5, and then I'm subtracting. It's 2 minus 1, and I don't have to write that 1. I could just write that as an x. Plus 18 divided by 2 is 9. What happens to those x's? 1 minus 1 is x to the 0. What's x to the 0? Nothing. I don't need to write that. The x's cancel out. The most important part of the GCF is the GCF. Don't forget that it's part of your answer. 2x goes to the front. Number 8 is 3 terms, but it might have a GCF. Do they all have variables? No. So I'm going to check 6 and 19, the first two numbers, and I can immediately see that they don't have a GCF. Right, so if that number's 1, then I can't do, there's no GCF here. What about the last one? Do they all have a variable? No, but let's see if they have a GCF.
Well, R9 is different.
Oh, it is?
Yeah.
What's it say?
It's 32x squared minus 72x squared.
Okay. All right, so let's take that, 32 and 36, is that right?
Oh, yeah.
All right, so they don't all have a variable, but let's see if they have a GCF. So math, arrow to the right 9, 32 and 72. All right, and then I'm going to take that number 8 and I'm going to pair it with the 36 that was at the end. So do they have a GCF? It's not x, but it's 4. So I need to divide a 4 out of all of these. All right, so we get 8x squared, 32 divided by 8. 1, 4. Thanks. That's what I'm just that. Minus 18x plus 9. Most important part of the GCF? Put it in the front. This isn't a equals 1 though. I can't do anything else, at least today, right? Because a is 8. So this is GCF when we can divide something out, and then a equals 1 as well when we have 3 terms. All right? So I'm going to have you finish class with some practice. That practice is specifically going to be GCF and a equals 1 practice. So you're going to be jumping around. Page 17, number 12, has a bunch of problems on it. I only want you to do the a equals 1 and GCF problems. The answer key is posted on Canvas. You can work with somebody else. You can grab your phone and listen to music. But here's where we're at for the rest of class, okay? So feel free to self-pace, right? When you're done, okay? But work on these. I promise you, factoring is the most important part of your final. I am also going to post some stations in the back. These are going to be up for the next 2 days, but these are open-ended stations. So if you're curious on what the format of your open-ended problems are going to be, these are going to be on the backboard. You can do all of them from the review we've done so far except for 2. There's an A is greater than 1 problem and a DOPS problem in here. That we'll go over tomorrow, but the rest you can do from our review. So if you want to work on this, I don't have like a template for it. You can just go back and work on it, and then the answer key is below it. Make sense? All right, so if you want to grab your phones and listen to music, you can.